This is The Water Table.
A chance to hear the agricultural side of these issues.
A place for people to go find information and education.
Water management is just going to become even more critical into the future.
How misunderstood what we do is.
I would encourage people to open their minds and listen to this dialogue.
Well, welcome to the Water Table Podcast. Today I have with me Eric Snodgrass. Eric is a science fellow and principal atmospheric scientist with Nutrient Ag Solutions out of Champaign, Illinois. It's going to be fun to visit with Eric. Today we're going to talk about the atmospheric delivery of rainfall, talk a little bit about soil health. We're going to get into the whole what's happening in the atmosphere and why we are seeing bigger rain events, sometimes double and triple the amount of 2+ inch rains that we've seen in areas of the Midwest, why that's happening. We're going to talk about how that impacts our growing season, making our growing season longer, and how it also impacts our workable days in the field. So really looking forward to this. I think we're going to talk a little bit about opportunities for farmers, how they should think about what they could do when we're looking at longer rain events and then longer periods between rain events of drier than normal weather patterns. So, Eric, welcome to the podcast. I'm really looking forward to some discussion here.
Yeah, thanks for having me on. As an atmospheric scientist, it's about the only thing I think about is water. So this should be a lot of fun.
Yeah, great. Well, we're going to also post on this on the podcast for people to listen to with some slides that you did of a talk I heard on a webinar a while back. But that's kind of what we want to talk about. One thing I took away from that right away as you started to deliver that was, just really what this is about is the atmospheric delivery of rainfall. And, how has that changed over the last 100 years? And what are you seeing that gives you confidence that we're in a pattern that probably isn't going to change for a while?
Yeah, when we look back at our historical statistics on precipitation patterns, the good news is we've got pretty good data going back at least to 1950, and then in some situations going back even to the late 1800s. So that's a long enough data set where we can actually start to analyze trends and patterns. And for the most part, when you look over that time period, what we tend to see is that in the southwestern United States and across the West, there seems to be a systematic trend toward drier conditions, whereas in the eastern part of the country, especially once you get kind of east of the 100th meridian, we tend to be, wetter. This includes the Canadian Prairie, the Northern Plains, all the way down into the central and eastern Corn Belt and clear to the south and southeast. For example, in my home state of Illinois, our growing season since 1950, so we call that like April to October, right? We've actually increased or seen an increase in total precipitation here of almost 5 to 5.5 inches of rainfall. So, that comes at the expense of not having the rainfall somewhere else, and changes in the jet stream pattern. Bigger ridges in the west are tending to rob better jet stream flow in the west. And the problem is that doesn't deliver the moisture there, it delivers it here. So yeah, these longer term trends are critical to watch and give us an idea year in and year out as to who's going to have that water when they need it and who doesn't. So it's kind of crazy to think that I live in a part of the world where you talk about drain tile, we want to get rid of the water when we've got too much of it. And there's other parts of the world that would take every drop that we could, we could send them.
So, you mentioned in their longer growing season in Illinois, just because of more rain and the weather patterns. But it's interesting because that, I think we all see that and can feel that, here in the last 10 years in Minnesota, what I've noticed is our springs tend to be cooler, not everyone, but cooler and wetter, and our falls have tended to trend warmer and drier. And when I've been working in this industry, in the ag water management industry for 25 years, and when I started, it was kind of in Minnesota. If you can get till Thanksgiving, you're still working at Thanksgiving, you've had a good run that fall. Now it's right up until guys just want to quit for Christmas. They probably could keep going. And so it certainly feels like it's changed. But where I'm going with that is longer growing season, but that doesn't mean that you have the same amount or more field workable days in the spring because of big rain events. Talk about that a little bit and some of your data on that.
Yeah, so I did a study back at the very beginning of 2020. One of the good things about COVID was that I got to spend a lot of time doing research because I wasn't on the road and wasn't traveling. And one of the first things I wanted to study was, are we seeing noticeable changes in precipitation frequency? Because I'd read several peer-reviewed publications about it. It's published in multiple government documents that are dealing with water issues. So what I did was I went back to 1980 till 2020, and I looked at the frequency of two things. Rainfall events that would, according to the USDA definition, kind of qualify as eliminating what we call a workable field day. And I also looked at the frequency of heavy rainfall events, which we defined as getting more than 2 inches of rain in a 24-hour time period. So what we basically found was from the ice states to Minnesota, even as far west as Nebraska, we were measuring that on average, due to an increase in the precipitation events in April and May, that we lost about 5, on average since 1980, about 5 workable field days. So that's just due to more frequent rainfall events. That doesn't mean every year that happens. It bounces around, but that's the average. Now, we haven't really seen the negative effects of that because since 1980, our planters have gotten bigger, badder, and faster, right? So we're keeping up with the changes here, but it does mean that our windows are tighter, which makes a lot of folks more reliant on accurate forecasts on when you can move equipment to which field. Now, the second part of that was across those same states, we have seen in like, for example, in Illinois, a doubling throughout the entire year in terms of the frequency of rainfall events exceeding 2 inches in a day. In Iowa and Minnesota, it's tripled. So a little bit further to the west and north, we're seeing more of these events that come through, deliver 2 inches of rain in a very short amount of time period, more than we did back in the 80s and 90s and early 2000s. So what that tends to mean is when we get water, what the soil can do with it, and in terms of retaining it and not losing stuff we don't want to lose, is critical, which means most of the discussions we have about the shifts in the climatic patterns that control rainfall is more about agronomically, what are we doing to help the soil sustain itself when those events occur? So yes, the water issues here tend to be bigger rainfall events and more frequent. But at the same time, in that same data set, what we also found was an increase in the frequency, an increase in the time length between big rainfall events. So what I guess you could say is we're tightening up our planting windows, but the planters are getting faster. And then throughout the growing season, our rainfall events are bigger, but they're spread apart farther.
Yeah.
So it's variability, and that's what we deal with in farm.
Yeah. Which all leads back to, the importance of maintaining soil health when you have those big rainfalls, and when you have a long period between rains. It's always been important, but it probably is, even more important with the variability that we're seeing the last few years or several years. Talk a little bit about soil health and how you see that impacted with these large, more than, like you say, double and even triple 2-inch plus rainfalls over the last, I can't remember, did you say 10 years or is that a longer period of time?
All the way back to 1980 on that research.
Okay.
The soil health issue, it's all about preventing erosion. It's all about preventing nutrient loss. Now, if we got a crop up and established, the crop helps prevent all of that, right? I mean, I saw a rainfall event that hit southern Illinois back at the end of, end of July, where we saw 12 inches of rain hit some fields. The crop was there to take it in and distribute. It was amazing what the crop was able to do. Never mind the town, which was completely flooded out. We saw something like that in St. Louis earlier this year as well. But if the crop is not in, and we get those heavy rains in spring, or we get them after harvest, it's all about having the soil in a condition where possibly it has enough debris on it, like from harvest, that You prevent the destruction of the soil simply by the pounding of the rain on top of it, or also the soil has got enough of its own, the tilt of the soil is such that it's held together, not broken up. And that tends to prevent it as well. Now, while I'm not a soil health expert, I get to talk to a lot of folks that do that. And so a lot of that discussion in those folks, it really revolves around tillage practices and how often we're in fields and what we do when we're in those fields. And it also has a lot to do with what the systematic changes in the tillage practices look like. Now, I've never tilled a single acre. I've sat next to a farmer pulling those things, but I've never been in the driver's seat. So I can't say that I have any sort of experience to tell you what I can say here. But having been out in several fields after big rainfall events, you can tell those fields that have been worked or even overworked in the way that they will lose a lot of content versus those that have maybe got a different type of tillage plan that allows for, honestly, just better resilience against that. So another thing I've seen that's really helped is some folks that have well-established cover crops rotations, when you got something green there in the fall when those heavy rains come through, it does just tend to do better. But I understand there's a lot of big decisions that go into whether or not you put in a cover crop or not, and there can be some major upfront expenses with that as well. But those are some of the things I've seen that have worked.
Yeah, and when you start talking about cover crops too, it kind of depends on your geographic location too. If you're up here in the further north in Minnesota, North Dakota, both the Dakotas, and you get a cover crop established in the fall, really good. It might really benefit you from when you have that big rain. But if you have a cold, damp, wet spring, it's really hard to get that ground workable again if you don't have subsurface water management in place.
You're 100% right, and that again, that's why these issues, while I tend to talk about them on 40, 70, 100-year timescales, the reality is every grower has a crop calendar that they're trying to keep to, which means every year presents a new set of challenges. And that's where I think the complications come in with, all right, how do I take these statistics and put it into a plan that I'm going to have? And as you just stated here, the geographical differences are huge. I'll tell you one thing that was pretty amazing. I did get to witness in Illinois back in 2019, which was an extremely wet spring. Here in Illinois, near a little river called the Embera River, I watched a farmer put in what he called a saturated buffer. Basically took the drain tile that used to go into the Embera River, and I don't know how else to describe it, but just to tell you, they put in like a little lock and dam system that would redirect that water into his buffer between him and the river and the road. He ran 900 feet of tile, 12-inch tile, one direction, and then another direction up the side of the road. What happened was when the tile was draining out of his field, redirected it, saturating the buffer, and therefore preventing that water from going out into the Embera River. Now, what was amazing about 2019 in Illinois was wet as spring, very wet spring. Then it didn't rain in July. In July, that guy was able to open that system and let water trickle in from the saturated buffer and almost reverse irrigate through his tile underneath. He said it got him he thinks about 10 extra bushel on that field. And by the way, the upfront cost for putting that system, because it was also an NRCS and someone else helped subsidize it. It was only $10,000 to put it in. It was an amazing bit of research and work that I saw there.
Yeah, there's so much going on with saturated buffers, just control structures, denitrifying wetlands, all kinds of stuff that really help with water quality. And water quality, we could talk about water quality a lot, but water quality even becomes a much bigger challenge when you see these 2+ inch rainfall events that are happening 2 and 3 times more than they used to. So we have a challenge in front of us that we've got a lot of opportunities and a lot of tools in the toolbox, but we're going to have to keep deploying them to stay ahead of these climate changes.
Sure, you're right. And certainly this was the year that in your neck of the woods, a lot of folks were talking about this. I think back about the way that the Red River flooded north of Grand Forks. I think about the flooding we saw in southern Manitoba. In fact, I followed this one guy on Twitter named Harley Siemens, And I think it took him 3 or 4 weeks to get home back to his farm because of the floodwaters in that area. That same region a year ago missed out on over 40 inches of snowfall, and they were in exceptional drought going into spring. So that kind of variability it just makes it challenging to farm successfully.
Yeah. Talk a little bit about, in your presentation, you diagram this and you have some slides that show it pretty well, but talk a little bit about kind of the why and those weather patterns. And you mentioned that just briefly at the beginning here, but what's actually happening with the jet stream?
Yeah, so going into any year, what we will watch out for any North American grower, this is kind of the thing we keep an eye on, is we pay attention to the Gulf of Alaska. All right, so if the jet stream is dipping in the Gulf of Alaska, we call that a trough. It tends to target most of the moisture coming from the Pacific into the Northwest. It then takes the jet stream winds and runs them right along the U.S.-Canada border, which draws then on Gulf of Mexico moisture to fill those storms up. So those type of years tend to be very dry south, like in the southern plains, into the mid-south and in southeast, while the northern plains tend to be quite wet. Then what occurs later in the season is if you keep that trough of low pressure in the Gulf of Alaska, we bake the mid part of the country with a massive ridge. You can completely flip that around. And if you put a big ridge in the Gulf of Alaska, most folks on the eastern side of the Rocky Mountains are having a phenomenal year. We tend to have more moisture. We tend to have good flow in the jet stream, more summer thunderstorms, and the crops tend to get plenty of water throughout the year. Plus, we avoid a significant heat stress. So that was one of the things I really focused on, was like watching the jet stream set up in the spring and early summer. It really telegraphs to us where to expect, where there could be heat and drought stress going into the middle of summer. Now, the only thing that we can use to kind of gauge whether or not the jet stream is going to do that, trough in the Gulf of Alaska or ridge, is ocean temperatures. And you probably hear a lot of guys like me going on and on about El Nino and La Nina. And here's it in a nutshell. La Nina events tend to favor troughs in the Gulf of Alaska. Therefore, heat and drought issues in summer in the Midwestern part of the United States. El Ninos tend to put big ridges into the Gulf of Alaska, which tends to mean that the West is very hot, a lot of wildfire activity and things like that, whereas the Midwest tends to have better summer temperature and precipitation patterns. That is a year in and year out thing, and we're just constantly watching for the changes in the behavior of the jet stream to see who's going to get the rain and who's not going to get it.
Sure. Well, that was a good explanation of that, and it made me think of, I've always heard kind of an old wives' tale around when it's really hot in the Midwest in the summertime, it means a lot of moisture, a lot of snow in the winter. Is there any truth to that from kind of how you just described that, or not? Is that just what people
that's
say?
a great question, and I'm trying. I don't know when I'm ever going to get this done, but I am trying to write a book right now. I've been collecting for the last decade all of these, I don't know if you want to call them wives' tales or wise sayings, or these things we hear about weather like this. And the reality of it is, and this is really quite important to understand, that seasons are not correlated. And what I mean by that is what happens in summer isn't correlated with what happens in winter. Let me tell you what I'm trying to say here. You go back and look at every bit of data we've got for summer weather going back to as far back as we've got it. And then you attempt to correlate that with the winter pattern. The correlation coefficients are near zero, which means just because it was hot and dry this summer here doesn't mean we're in for it for winter. But that doesn't mean we couldn't have a brutal winter. But it's controlled by different things. So this particular winter, could we have gone from what was a very hot and dry summer for many in the midsection of the country to what could be a colder winter? It certainly could. We still have a La Nina, and the La Nina is strong. It tends to take the jet stream in winter, bringing it straight out of the Canadian prairies through the Midwestern part of the United States. And that's a lot of cold air up there. It tends to be snowier as well. But could the polar vortex stay strong and keep the coldest air away? Or could the polar vortex go weak and let all that cold air out? That's a possibility. Will the North Atlantic behave? Because if the North Atlantic puts a big ridge over Greenland, then we are done. It will be cold. The rivers will freeze. We'll be very, very cold this winter. But if that doesn't happen, then there's no reason to really deliver all that cold air. So I guess what I'm trying to tell you is we watch at any given time about 12 different factors in the Pacific and in the Atlantic Ocean that at any given time could be the most dominant forecasting feature. Most of them are subseasonal, meaning they fluctuate on 2 to 3 week timescales, not on seasonal timescales like month to month. So the reality of it is that if any of us could accurately forecast 3, 6, 9 months in advance, you'd never hear from any of us. I wouldn't tell you about it. I'd be a multimillionaire, I'd make all these trades on the grain and energy markets and I'd be gone, right? So the fact that we still discuss it means that it's speculative and a lot of different factors control it.
Yep. Well, good. I enjoyed listening to that explanation. If you haven't heard this one for your book, one that I think is so true that I heard a long time ago from an old guy was, it takes a long time to get dry, but it only takes 1 day to get wet. And that is so true. And when I heard it, I didn't know. I thought, I had to think about that for a minute. Is that really reality? But, with what you're saying now of 3 times the amount of 2-inch rains in Minnesota, Iowa region, it's totally true. And we even seen it this year as we were pretty dry in Minnesota going into our growing season, and we got 5 to 7 inches of rain over 3 days in May, and then all of a sudden that kind of pulls you through. Kind of wanted to switch gears to that area around yield variability due to moisture, and again, what we're talking about with all the variability with rain and more rains and then longer periods between these rains. It really can wreak havoc on yield and just being consistent. But I've also seen the last couple of years some areas that really were short on rainfall, from an average standpoint, but still had really good years. And, I always attributed that really just to the science in the crop and the seed technology, more drought resistance, those kind of things. But is that how I should be thinking about that, or is that due to timely moistures, or talk a little bit about that?
You bet. So let's just go back to last year, 2021. I was getting phone calls and text messages and emails from folks all across Iowa and southern Minnesota. And the questions were about, we have been so dry, we're off by 6 to 8 inches in total rainfall in certain places. Are we going to see yield numbers like we saw in 2012? And I went up there and I walked fields, toured the place and had a look. And there was one thing that I could add to your comment about what seed technology is doing. Because to be honest with you, I think personally that the increases in yield potential and then resistance to adverse weather effects that we've seen put into the technology of growing these seeds and developing them is making us less vulnerable. But it doesn't mean it's invulnerable, right? This is what I saw last year. During some of the driest stretches in July and August, humidity levels were up about 6 to 8% above normal. So what was going on was every night, well, not every night, but most nights, even though the low temperatures were just coming down almost about 68 to 70, which is too warm, we want them cooler than that, we were still able to hit the dew point. So I would walk through some of those fields in the early morning and I'd see a little ring of water around the root ball, and I'd come out soaking wet. So even though it wasn't raining, moisture was still getting into that crop. And it was just enough to sustain it until you got into the beginning of August last year, where the atmosphere opened up and rained like mad. And so what happened is we had this conversation in July where everyone's like, this crop is going to be terrible, to then wondering if there's going to be enough space in the bins to contain all of it. So sometimes the atmosphere is doing something, helping things out, and it's hard to observe because I can measure rainfall all day long, but knowing what that dew point's doing, giving you the moisture from the dew, that's a trickier thing to observe. So we didn't even see it until the season was over, and all of a sudden, like, hey, these ears are long, they're fat, they're making big kernels. What happened? And I had to go back and look at it and say, we had plenty of dew last year. So the seed tech side of it adds to that in a big way because that crop was able to stay alive and use less of its own energy to stay alive, and therefore reserve that sugar to eventually get into those kernels later rather than using it to just respirate it because there was moisture there.
Yeah. Well, interesting. I'm glad I asked that because I hadn't really thought it through that way, and enjoyed listening to that answer. As we kind of wrap up here, I'll give you opportunity kind of to tell us things that you think we should know too. But I do have one more question. And, what would you say kind of the number one thing a farmer can do to keep stability in his or her operation, knowing what you know about atmospheric rain delivery and, how you think that's just going to continue to be a lot of variability in that?
Yeah, I'll tell you this. The first thing I would do is, if I were a farmer growing in these conditions, I would get my hand on every bit of research from the extension offices, from the big public universities. I would talk to as many agronomists as I possibly could. I talked to my farmer friends, and I would just listen and take in the information that they can share with me about what's helping them stay resilient, what's in those articles about soil conservation practices, about drainage, that's making folks more resilient to any sort of weather event, right? And then what I would do is I'd step back and do an analysis on the return on investment. So for me in Illinois, would it pay for me to pattern tile or retile? I'd want to know the answer to that. If I change my tillage practice with that, if I change my rotation, I would just want answers to those questions. In other words, what I would want to do is I'd want to challenge myself through research, like real research, reading peer-reviewed publications, reading what the extension offices are saying, and I'd want to then see if I could make a strategic change in my operation to be more efficient. Because that's the one thing I can control is efficiency, because I can't control the markets and I can't control the weather. But if I can control my efficiency and preserve that soil, I would go after that. The second part of this is, and this is just, it's a little bit different, but I would never, ever bet the farm on a forecast. And what I mean by that is, guys like me, we look out there very speculatively say, gosh, the risk of drought is this, or the risk of flooding rains is that. The reality is, the best farmers I've ever met in my entire life, which I would define as most successful, which means they get to retire and they have a succession plan to pass that farm on and didn't ruin it, right? Those guys, I call them base hit farmers. Year in and year out, base hit farming. They never swing for the fences. They make systematic changes so that by the time that at the end of their career, they have built up this farm that's sustainable, that the soil's been taken well, the crops are successful. And they do that by just staying ahead of what the research is saying. And I hope that if I ever get to farm, I'm one of those guys.
Well, I appreciate that answer. And it's just what you do. The successful people in life are the ones that show up. And I don't know, what was it, Vince Lombardi that said they're just consistent every day.
That's right.
Just continue to do the same thing. So
I want to be the Pete Rose or the Nolan Ryan of farming, right? Well, I know Pete Rose got in a little trouble, but whatever. He got a lot of hits. If Nolan Ryan stuck him out.
now we're just chatting, but if you like Nolan Ryan and you haven't seen the documentary Facing Nolan yet,
yes,
it's awesome. It's really
I
good.
haven't seen it, but I saw it the other day. I saw it advertised the other day. I was a kid when he was pitching, and I remember sitting next to my dad. He's like, just watch this guy. I actually watched that game where he got the famous one where he came up and just decked the batter that he kept sweeping off the plate. I was just like, Dad, how is this guy your age and still throwing 103 miles an hour?
You got to watch it. My wife doesn't really like baseball, but I watched it on an airplane a few weeks ago and I came home and I said, we got to watch this. And she watched the whole thing and enjoyed it a lot. But what's really good about it is they put it together really well, just like kind of like his career, where it kind of starts and just builds and builds and builds upon itself. So by the end of it, you're like just about standing up watching it, because it's really, really well done. And I will watch that.
So
anyway, that's a tip for you and our listeners here. Watch Facing Nolan, the Nolan Ryan documentary. So anyway, Eric, I really appreciate you joining us here on the Water Table. And anything you want to leave our listeners with, or any last words? We'll give you the...
I'll leave you with this. If you think some of the issues that we're dealing with here in the States with respect to water and its delivery from the atmosphere, there are other places around the world that are dealing with even more significant issues. And right now, what's front of mind for us is South America. The South American monsoon has actually been, in the month of October, over the last 40 years, been weakening. Now, this year it's going to start on time, but in the last 40 years, it's been slowing down a bit, and that's really compressing their crop calendar. And my friends in Brazil will also tell you that the rainfall delivery variability, just like we talked about in the Midwest, it's also increasing. But the issue down there is they don't have Midwest soils. Their soil is very sandy, it drains very quickly, which means the water issues seem to be exacerbated there. So just something to think about, that, ag is a global game now, right? It's been for a while, and we have to watch these other areas and how weather's changing there to maybe affect our market prices. We do that all the time. So I would just say this issue we're discussing today is not just a Midwestern issue. It's a global issue that deserves a lot of research and attention.
Yeah, thank you very much for that. When one thing that happens for sure here in Minnesota is, we're a land of 10,000 lakes, and we get plenty of moisture, and we just forget about, even in the U.S., but for sure globally, about the fact that water is not an issue for us. It's an issue every, once in a while when we have a drought or we get a 7-inch rain or something, but not in the way of every day thinking about, how do we manage our water so we don't run out? Never think about that.
Oh, yeah. Well, I tell you, I'm so interested in this topic that I just finished reading a book called Where the Water Goes. It's about the Colorado River. If someone's listening today that's really interested in that, that's a great book. It's called Where the Water Goes. I believe the author's name is David Owen. I'll have to double check that, but Where the Water Goes. And I'm going to actually read next week a book called Cadillac Desert. That was one that was suggested as well. So it just talks about these water issues in the West, which are, they're difficult to understand, and it's a very important topic to study. But yeah, those are two books I'd recommend. And what was interesting was in David Owen's book on Where the Water Goes, he recommended watching the movie Chinatown. Remember that from the 70s with Jack Nicholson? I'd never seen it. So you talked about watching something on a plane. I watched that one on a plane. I got off at Elena, that's my wife's name, we got to watch this together because I want to see it again. Because it's actually all about murder due to water rights and things like that for LA. Incredible movie, and it deserves the accolades it got. So yeah, that's a lot of research I'm doing now. So what's going on in the West?
Yeah, good. Well, thanks for your time. Hopefully, we can call on you again sometime here at the Water Table if we've got questions about what's happening weather-wise, and really appreciate what you're doing for all of us here, and the research and the things that you're providing for American farmers.
Yeah, you bet. I enjoy doing it, and Nutrien's been a great company to kind of facilitate that work. So I'm pretty happy.
Thank you, Eric.
Thank you.
Thanks for joining us today on the Water Table. You can find us at watertable.ag. Find us on Facebook. You can find us on Twitter. And you can also find the podcast on any of your favorite podcast platforms.